Okay. So we want to go from centimeters to meters. Still going to erase all this. So I'm going to highlight that. We want to go from centimeters over to meters. Meters is the basic unit. So one way this is taught, and there's no problem with this, is that when you look at the chart, if you want to go from centimeters to meters, all you have to do is count how many spaces you moved over on the chart. So how many spaces did we move over to go from centimeters to meters? Well, we jumped, what, 2 spaces, right? So what that means is that we can take our question right here, and we can identify where the decimal point is. And all we have to do is move that decimal point 2 places to the left, because that's what we did on the chart. We just moved 2 places to the left. So if I move that decimal 2 places to the left, I'm going to get 0.0058. So hopefully you see that that decimal used to be right here, but now it's jumped over to the left 2 places. So if you use that method, there's no thinking to it. All you're doing is just following like the chart and how many spaces you move left. And that's it. There's actually very little to have to process.
Could you explain that again? I'm sorry.
Okay.
I'm a little confused.
Okay, so if you're working with the metric system and you want to go from one metric unit to another metric unit, but in this case, we want to go from centimeters to meters. The easy, quick way to do that is to go up to the chart, find centimeters, find meters, and then ask yourself how many spaces you have to move over to get from centimeters to meters. So we had to jump 2 places to the left to get from centimeters to meters on the chart. So that means that what you'll do is you'll go to the problem, and wherever your decimal point was, in this case it was right before the 5, we're just going to take that decimal and move it 2 places to the left. So it actually went from, it used to be right here, it moved 2 places to the left and appears here now. So our answer would be 0.0058 meters. Does that make more sense?
Yes, thank you.
Okay. Now, that's a nice, easy, clean way of doing it. But like I said, I want to try and show you something that's going to be more helpful to you later. So I'm going to show you an alternate way of doing this. And it might confuse you, and you may be like, I'm just going to stick with the chart, like just moving over, that's fine. But like I said, later on, this will be helpful. So go back over here, and what I want you to do is, I'm really contemplating whether or not I want to do this or not. You know what? Because I don't want to confuse you more. Let's stick with the moving on the chart for now, and then later on when I get to the other stuff, I'll deal with it then. I'm making kind of a detour off of what I had planned to do, but let's just see how this goes. Let's look at number 2. All right, and number 2, we have 4.7 kg. So K and G. We go to our chart. I'm going to look for K and G on here. So G we know is the basic unit is grams. And then the K in front means kilo. So here's where we are. We're starting here at kilograms, right? Kilograms. And we want to go from kilograms to grams. So if I go back to my chart, I'm going to have to move, let's see, 1, 2, 3 places to the right this time, right? So if to go from kilograms to grams on the chart means 3 places to the right, that means on my answer, all I'm going to do is take the decimal point right there, that 4.7. I'm going to move that point 3 places to the right. So I'm going to write it down up here. 4.7 is where I was. I'm going to go 1, 2, 3 places to the right, and I'm going to place the decimal there now. Anywhere where I have gaps, I'm going to put 0. So this is going to be 4,700 grams. So 4.7 kilograms is 4,700 grams. Is that clear to everyone?
Yes.
Okay. Let's look at number 4. I'm going to skip number 3 because number 3 is the same as number 2. You're going from kiloliters to liters, so it's the same 3 spaces. So I'm going to leave that one alone. But on number 4, we have 0.098 grams, and we want to go to mg. So let's go see where that is on the chart. So I want to go from grams. So grams is in the middle. All right, it's the basic unit. And I'm going to go from that to mg. Mg would be milligrams. So how would I get from grams to milligrams? How many places would I have to jump, and which direction?
3 places to the right.
It's going to be 1, 2, 3 places to the right. So that's what I'm going to do to the decimal point. I'm going to move it 3 places to the right. So I take this 0.098, and I'm going to move the decimal point 1, 2, 3 places to the right. And when I do that, I'm going to put 98, just 98, because the 0 in front of the 9 can go away because our decimal point has moved. It's actually right there. I don't need to write it because 98 is 98. But we have 98 milligrams. And that is it. So where can this get tricky? Let's see. So yeah, this one's going to be tricky. Let's take a look at number 9. Number 9 is a little bit tricky. So we have 2,000 mg. So mg stands for milligrams. And we want to go from milligrams over to, what is that? It's like this little U in front of the G. Let's go see where that is on our chart. So we're trying to go from milligrams over to this weird little U-shaped thing. All right, so here's M. So I'm trying to go from milligrams over, here's the U, that's micrograms. So here's the tricky part, so please pay attention to this. It appears from what I've been telling you that to do this, all you have to do is jump 1 place to the right. Would you all agree? I mean, if you're just looking at the chart, that's what we've been doing. But the problem is there's actually a bunch of conversions in here that the table doesn't show. So I want you to pay attention to something real quick. Look at the powers on right here. We have 10 to the 0, then 10 to the -1, -2, -3. So notice how those are just changing by 1 each time. But on the next one, it's not -4. What is it? It's -6, right? So as you jump from one to the next, they change by 1. They change by 1. They change by 1. But this jump, how much does that number change by?
3.
3, right? So the jump from milligrams to micrograms is not a jump of 1. It's actually a jump of 3. And the other direction, you'll notice that every jump is 1 until you get to this one right here. From kilograms to megagrams, that's a jump of 3. So you just have to pay attention to that. In this particular problem, going from milligrams to micrograms, we're not going to move the decimal point to the right 1 place. We're actually going to do it 3 places. So please make note of that. The table is somewhat deceiving in that way. So I'm going to go here and I'm going to find my decimal point, which is right there. And which way am I going to move it? Which direction, left or right?
Right.
Right, and then I'm going to go by 3. So I'm going to have the 2,000 that was there, and then 1, 2, 3. So I have 3 zeros I'm going to pop in there. So it's really going to be like 2 million. 2 million micrograms. Okay. Now, here's where things get even crazier. Y'all ready for this? I'm going to try and explain this the best way I can. I want us to take a look at a picture. I'm going to draw something here. I'm gonna tell you right now that this is 1 meter by 1 meter. Okay, so it's like a little box, a little square. It's 1 meter long, 1 meter tall. If I asked us for the area, then what you do is you'd multiply this times this, and you get 1 times 1, which is 1, and then meter times meter would be meter squared. And so that little squared up there is telling you, again, you're talking about an area measurement, not a length. So the area of that square is 1 square meter. The question is now, how many square centimeters is that? Okay, so let's go up to our table and take a look for a second. Our table tells us that to get from meters to centimeters, right? Meters to centimeters, I have to go to the right 2 places, don't I? In fact, one way of looking at this is that there are 100, okay, that's why it says 1/100th here. There are 100 little centimeters in 1 meter. So if I move my decimal point 2 places to the right, okay, to go from meters to centimeters, if I move my decimal point 2 places to the right, then what would this become? What would that right there become if I move the decimal point 2 places to the right? So my decimal's right there next to the 1. Move it 2 to the right. It would become 100, wouldn't it? Everyone agree with that?
Yeah.
But that's wrong. And the reason it's wrong is because, think of it this way. There's if you take a meter and cut it up into 100 little pieces. Now, that's not 100 pieces, but just the idea here is that you cut this up. Each one of those is a centimeter. That's how wide it is. But if we cut the other direction into 100 pieces, each one of those is a centimeter. So this little box, can y'all see that little box in the lower corner? That little tiny box in the corner is 1 square centimeter. That's 1 square centimeter. How many of those little boxes would I have just along that first row? Just down here. How many of those little boxes would I have down there across the bottom?
100?
100, right? Because there are 100 centimeters across. And so by moving the decimal point 2 places, didn't we say that we would have 100 square centimeters? That's completely wrong. That only accounts for that bottom piece. Don't we have all of these in here? I mean, there's so many of them in there. How many are there? 100 across the bottom and 100 across the top, right? So moving the decimal point 2 places to the right didn't work. I can barely hear you if you're asking me a question. It's barely coming out to me. All right. Oh, I heard something again. I don't want us to get bogged down with this picture, okay? I just want you to understand that the method of moving the decimal point 2 places is not going to work. And the reason it's not going to work is because we're talking about square units. So I want you to focus all of your attention to that problem right there, okay? If we're going from a squared unit to a squared unit in the metric system, which we are here, I'm looking at number 10 right now. We're trying to go from 4 square meters over to centimeters squared. What you have to do is go from meters to centimeters, like we do on the chart. We have to go from meters to centimeters, but we have to do it twice. And the reason we do it twice is because there's, oops, I went too far. Is because there's little twos, there's twos up there. We're talking about areas. So instead of moving the decimal point to the right 2 times, how many am I gonna move it? Because you have to do it twice.
4?
4. So I'm gonna take that 4 and I'm gonna move that decimal point 1, 1, 2, 3, 4. And that's where I'm going to place it. And I'm going to have 0, 0, 0, 0. So that gives me 40,000 square centimeters. The reason we didn't do that on the previous problems is because, like, when we went, let's say on number 4, when we went from grams to milligrams, it wasn't grams squared to milligrams squared. It was grams to milligrams, so you just follow the chart. If those things are squared or cubed, you have to repeat the process. So look at number 11. I think number 11 would be a good kind of final exercise here for this. On number 11, we're trying to go from HM cubed to centimeters cubed. So whatever we do on the chart, we're going to have to do it how many times?
3.
3 times. 3 times. So let's go to our chart. Let's find H on our chart. H is right here. And we're trying to go from, what was it, hectometers to centimeters. So we're trying to go from hectometers all the way to centimeters. So how do we get there? We have to move 1, 2, 3, 4 places to the right. But because it's cubed, we're going to have to do 4 times. Move the decimal point 4 times over, right? 4 spaces, 3 times. So how many spaces are we actually going to move?
12.
12 times. So we're going to take this 0.00025 and we are going to move it 12 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put a decimal point there. Fill in all the zeros. And
the
then,
reason 3 times is because it's cubed. So like the last one, it was squared. That's why we did it twice.
that's why we did it twice. Exactly. So here we're going to hit 2, 5, 0, 0, 0. How many zeros do I have there? 6, 7. So that's like 250 million cubic centimeters. Okay. I hope that that makes sense. Number 12, I'll leave to you, but you have 130.4 billion square meters, and you want to move that to square kilometers. So you're going to move over on from meters to kilometers, but you're going to do it twice because it's square units, and that's because it's a measurement of area. Okay, I'm going to let y'all go through those and see how that goes on your homework. All right, now let's talk about the imperial system. All right, remember I told you that story about the probe we sent to Mars and we lost it. It was because some engineers were using imperial, the others were using metric. Well, these problems here are an opportunity for us to convert between the different systems and within the imperial system. So let's take a look at this first problem here. We have 21.5 inches, okay? So I think we all know about how long 21.5 inches is. The question is, how many centimeters is that? All right, so here's where things are gonna change drastically because we can no longer use the chart above and just move decimal points over. We can't do that because inches is imperial and centimeters is metric. And so you can't use the chart. The only thing you can use in this case is this right here. This is what we're allowed to use. So is there anywhere on that chart where I can get from inches to centimeters? Do y'all see anything on here that allows me to get from inches to centimeters?
First row, 1 inch equals 2.54 centimeters.
Yeah, there's something right there. It tells us exactly how much 1 inch is. So 1 inch is 2.54 centimeters. So watch what I'm going to do here. I'm going to just write this down on the side. 1 inch is equal to 2.54 centimeters. Okay, do y'all remember when we were doing the problems on proportions, when we were talking about, this is last class. Let me scroll up to it so you can see what I'm referring to. Do you remember these problems? Where are they? Here we go, proportions with, like, you know, one bagel has 320 calories. How many calories are in 2.5 bagels? And do you all remember when we did this, where we set up these proportions and we said, oh, well, that means that one bagel is either 320 calories, or we could say 320 calories is one bagel. We wrote it both ways, and then we came over here and we did something with it. We're going to do that exact same thing. Okay, so I'm going to show you. Let's like get back down here. Okay, I'm trying to go from inches to centimeters. And here's what I know. I know that 1 inch is 2.54 centimeters. So what that tells you is that you have two conversion factors here. 1 inch over 2.54 centimeters. Oops. 2.54 centimeters is one way you could write it, or you could write it 2.54 centimeters over 1 inch. So you have these two conversion factors that you're free to use either one of them. Okay, so we're going to determine which one it is, but what we'll do is we'll start out by writing down the left-hand side, 21.5 inches, and then what you'll always do is you'll put that over 1. So what we're doing is we're making a fraction out of it. We're saying 21.5 inches over 1. Well, that's still 21.5 inches. Now what we'll do is we will multiply by one of these two. And does anyone know which one I'm going to use and why I'm going to use it? Am I going to use the one on the left, or am I going to use the one on the right?
Left,
Okay, so why would you think I use the one on the left?
because last time we were using it, you wanted to have the same, like inches would be at the top in this case. You want them both on the same side.
Okay, yeah, so in the previous things that we did, we wanted to have it match up, right? Like inches on top. If inches are on top, we wanted inches on top on both, right? Now, the reason we did that, I'm going to go back up here. The reason we did that is because what we did up here is we set up, I'm going to look at it right here. It's going to be hard for me to do this without erasing everything. Let me get this out of here. Okay, so if you look at this, what we did is we started out with what we were looking for, calories over bagels. And then on the right-hand side, we put the same thing, calories over bagels. But the difference in the problem was that we had an equal sign. And because we had an equal sign, we wanted the same thing on top and bottom. These problems are different because we don't have an equal sign. What we have is multiplication. So right now, I have up here inches on top, don't I? And I want my final answer to be in centimeters. So I want the inches to go away. So what I'm going to do is use the fraction that has inches on the bottom so that it will cancel with the inches on the top. So let me write it down. 2.54 centimeters over 1 inch. And then what you can see is that these inch units cancel each other out. And then you no longer have inches. All you have left is the centimeters. Does that make sense? It's different from before. It's the same in the sense that we're going to come up with two fractions or two proportions. But the way we implement them and use them is going to be a little different because we're using multiplication in the middle and we're not setting them equal to one another. So if I do that, and I need my calculator for this, I have two fractions I need to multiply. So all I'm going to do is multiply straight across. So I'm going to take 21.5 and multiply that by 2.54. And I'm going to get here equals 54.61 centimeters on top. And then what number is still on the bottom? You're supposed to 1 times 1, right? But we don't need to do 1 times 1. 1 times 1 is 1, and we could put it underneath that, and it wouldn't matter. It'd still be the same thing. So that is our answer, 54.61 centimeters. Okay, so there's similarities in things that we've done before, and there's differences. Hey, I wanted to tell y'all, I've been trying to figure out the best configuration for my stuff here. And I really want my camera to be right in front of me so that when I'm looking at the screen, I'm looking at you like this, but I just can't. I don't have enough depth in my office to be able to do that. And I'll show you what I've got here. This is my setup. So I've got like a tablet I'm writing on, and then I've got you guys in front of me, but that's where my desk is. So I can't put my camera back here. It doesn't work. It's too close. So I apologize that I'm having to, that when I'm talking to you, I'm like this, but y'all are actually over there. So maybe I'll try this. Okay. Let's try another one. I mean, you only get good at these after you do some practice. So let's try this other one. And you know what the real sad thing is about these problems is that, like, if you really wanted to do this, right, you could just like get on your phone and be like 21.5 inches to centimeters.
21.5 inches is equivalent to 54.61 centimeters.
Right? Like, it's so easy to do on our phones. That's not the goal here. The goal here is to understand how we use conversion tables and how you set up these proportions and do the math behind it. All right, here we go. I'm going to do 120m, right, over to YD, which is yards. So I'm going to go from meters to yards. Now, meters is metric, right, and yards is imperial. So is there anywhere on our conversion table where we go from meters to yards? So let's go look. Does anyone see anywhere where we go from meters to yards? Does anyone see it?
Just the feet.
Man, this thing is really not working today. I don't know what's going on.
And do you have to go from yards to feet, then feet to yard, or feet to meters?
Yeah, so there is no conversion, right, that we can see that goes directly from meters to yards, right? So I'm going to write down here what we're trying to do. We're trying to get from meters over to yards. In fact, why don't I go ahead and go grab the number? We'll do all the work up there. I'm trying to go from 120 meters to yards. Okay, so there is nothing that relates meters and yards together on this conversion table. The only thing I have really that looks useful is that I have a way to get from meters to feet and feet to meters. So I have a relationship between feet and meters. I'm going to go ahead and write that down. I'll do it in a different color because this is kind of like my scratch work. I know that 1 foot is equal to 0.3048 meters. Okay, y'all agree with that? So there is a way to get from meters to feet. So I could take this meters and I could get it to feet. Now, is there a way to get from feet over to yards? Well, there is, right?
Yep.
I have this other relationship of feet and yards. So I have this second relationship that says that 1 yard is 3 feet. Okay, now, we should then be able to get from meters to yards. It's going to take us 2 steps. We're going to have to go from meters to feet and then feet to yards. So for each one of these equalities from the conversion, from each one of these, we also have the ability to set up our 2 proportions. So one of them will be 1 foot over 0.3048 yards. I'm sorry, meters. Or I could write it the other way around, 0.3048 meters over 1 yard. And then on this side, I could put 1 yard over 3 feet, or I could write 3 feet over 1 yard. Do you all understand that? Each one of those has 2 separate scenarios. So now it's time to do the problem. I'm going to take 120 meters and I'm going to put it over 1. And then I'm going to multiply it by something. And what I want is for the meters to go away. I want the meters to cancel. So which one am I going to use to make the meters cancel? I've got essentially 4 different conversion factors I can use here. So which one am I going to use to make the meters go away? What?
Meters to feet or right?
Yeah, the meters to feet. So which one of those 2 am I going to use? The 1 foot over the 0.3048 meters or the 0.3048 meters over the 1? Oh, you know what? Hold on. This was,
The first,
sorry, I messed up right here. That right there was supposed to say what?
feet.
Feet. I apologize. I didn't catch that.
It'd be the one on the left.
Yeah, this one was supposed, this one's okay. Sorry.
Yeah.
Yeah, so we're going to want to use this one right here, the one on the
Yeah.
left, because the meters on that one is on the bottom. So 0.3048 meters here and 1 foot here. And that way the meters, again, will cancel. And that's what I want. I want the meters to go away. I don't want this thing in meters. I want it in yards.
So you want
So
them to be opposite of each other. So if the 120 was at the bottom, so if 120 meters was at the bottom, you would put it on the other side at top, so it could
Yes.
cancel out and be opposite of each other.
That's right. Yep. Okay, so right now, as if I were to do this, if I were to multiply across right now, my answer would be in what unit?
Feet.
Feet, right? That's not what we want. We want yards, right? So what I'm going to do is next to this, I'm going to put another fraction I'm going to multiply. But I want the feet to go away now. So I want the feet right now are on top. So like I think Sarah, I don't know who said that, Sarah, I think it was you. I want the feet to go away. So I'm going to put feet on the bottom. So I'm going to be using this one in blue because it has the feet on the bottom, even though you can't read my writing. That has feet on the bottom. And so what am I going to put? I'm going to put 3 feet. You got to have that 3 there. 1 yard, like that. And now you see the feet go away. And so now my answer is going to be in yards. So I went from meters to feet, and now I went from feet to yards. And then, you know, all I have to do now is get on my calculator and do 120 times 1 times 1. So I do that across the top, get 120. I also get yards because that's the only unit left. Then on the bottom, I do 1 times 0.3048 times 3. So I need my calculator for that. I'm going to do .9144 on the bottom, and there's no units there because everything canceled. And the last step will be to do this on my calculator, 120 divided by that. And I'm getting something like 131.23 yards. All right, does that make sense?
On the test, on like for like testing purposes, are you gonna want to see that whole thing, all that? You can't
Yes,
just
I
like
am.
do it. Okay.
Yep.
All right. That's,
Yeah, I mean,
got you.
sometimes, you know, like in the real world, like this stuff is important in the real world for like, especially in like the medical field. This is really important because they have to convert like, you know, milliliters to liters. They're giving medications and they need to be able to convert. But doctors, they use apps on their phone for that. Like they have ways of doing it. They don't leave it to human error to make mistakes. But for this class, the requirement is that if I give you something, you should be able to convert it by doing this little chart with the conversion factors.
Okay.
Sorry, I don't know if you answered this question or not already, but are we going to have a chart available to us? Like, are we going to be able to use
Yes.
it?
Yes. Yeah, I'll send out, I mean, at any point in time, feel free to print this page number 25 on your own, like just print it out. But during the test, I will send it, it'll be with the test. So when you open the test, it'll be like the last page or something,
Oh, okay. Got it.
okay? But I'll invite you to print it if you have the ability to print, because then you can have it in front of you instead of having to like get on your computer and move around. And okay. Let's do some, we got to do some more of these because they can be confusing. How about this one? Let's do number 3. We want to go 55 miles to meters. 55 miles to meters. So I'm going to erase all this. And I cannot believe my computer is so laggy right now. It's really driving me crazy. Man. I'm wondering if it's because I have something open in the background.
Can you disable your video? It might go faster.
Yeah, well, I did that earlier and it didn't help. But just give me a moment. Oh, close tabs. Let me see. Oh, here it is. Let me just see if what things are running on my computer real quick. It says my RAM is fine and CPU is fine. I don't know. It's weird. I'll try disabling my video a little bit. Okay, let's see if that makes it any better. In fact, you know what I'm gonna close that. Close that. I'm gonna close Excel because all these programs just eat up so many resources. Okay, here we go. That's better. Much faster. Okay, it was 55 miles. And we want to get that to M, which is meters. So we want to go from miles to meters. So do we have anywhere on our chart where we go from miles to meters?
Mile to feet.
Okay, we do
And
have a
feet.
way to go from miles to feet. And then what?
Yeah, miles to kilometers.
We also have miles to kilometers. So one thing we could do is we could go from miles to kilometers, and then kilometers, we should be able to go to meters because that would be a metric conversion. You don't want to try that? I think that might be
Easier.
the easiest way to do it. So we want to look at this one right here. Man, it's still really laggy. Let me try something. I probably should have just like restarted my computer at some point, but let's try this. Okay, so what I'm going to do is I'm going to try and figure out That right there gives me two different conversions. So I'm going to write those down. I have 1 mile over 1.609344 kilometers. It's one way I could write it, or I could write it the other way around. 1.6093. I don't need you to write both of these down on the test. If you do the actual computation properly, that'd be fine. I'll show you what I mean. So like if you do this, everything I'm going to write in blue here. So here's the original problem. Okay, so if you just take that and down here you write 55 miles over 1 times, and then if you realize you're going to use this one because miles is on the bottom, and then 1.609344 kilometers on top. That's fine with me if you just write that down and then do your canceling and then use your calculator to go straight across. 55 times 1.609344. And so you get 88.51392 kilometers. So that's where we are. But we're not done because we want our final answer to be in meters, remember? In meters. So how do we go from kilometers to meters? This is where we go to our chart, right? So we want to go from kilometers to meters. That. So what are we going to do to our answer that we have so far?
3 places to the right.
3 places to the right. Yep. 3 places to the right. Okay. I'm going to do that in just a moment. I want to see if, where is that thing? Yeah, that's okay. Okay, so 3 places to the right and we'll be done. So I'm just going to go 1, 2, 3. So we get 8,513.92 kilometers. Here we are. That's it. Okay, I think we should do one more. All right, do one more, and that should be enough to get you going on this. I'm going to go and do, I think let's do number 4. So I want to do 1.25 inches to centimeters squared. Yeah, or was it inches squared? Sorry.
Yes.
Okay. Can y'all tell from your end how laggy this is? You probably can't.
No, it's pretty laggy.
Yeah, it seems real laggy. Okay, so 1.25 square inches, and we want to convert that to square centimeters. Okay, that's what we want to do. So do we have any way to go from inches to centimeters? Well, we do, right? It's that first one that we had. So here's the difference. because we have the squared, what did we do on the table when we were doing metric conversions? What did we have to do when we had squared in terms of moving the decimal? Didn't we have to do it like twice if it was squared and 3 times if it was cubed? Right? So watch the way I write this. I'm going to write 1.25. Now I'm going to put inches squared, but watch the way I write this. That's inches times inches. So instead of writing inches squared, I wrote inches times inches, which is the same as inches squared. And then I'm going to multiply by 2 conversion factors to make the inches cancel twice. So the first conversion factor I'm going to use is 1 inch, and on top 2.54 centimeters. And then next to it 1 inch, and then 2.54 centimeters again. And what I'm hoping that you're seeing is that I have to do it twice because the first time I do it, the first inch cancels. And then the second time I do it, the second inch cancels. Not only does that happen, but now you've got centimeters twice, which is going to give you your centimeters squared. So now all you have to do is multiply straight across, which I'm going to do. So I'm going to do 1.25 times 2.54 times 2.54. This gives me, and I'm going to have a 1 on the bottom, so I'm not worried about that. So this gives me 0.0645 square centimeters. Oh no, I did that completely wrong. I'm sorry.
I got 8.06.
Yeah, I need my glasses. It's kind of dark in here too. 8.0645 square centimeters. There we go. Okay, that's it. All right, so I'm just gonna kind of warn you now, you know, on these next ones, you know, it's more of the same, all right? But there's some here that go, you know, from cubic to cubic, which means you'll have to do it 3 times. And then I think I'm gonna do one of these, but I think right now, let's take a break, but I'm actually gonna close the session out. I'm gonna close off the meeting and I'm gonna have y'all come back. Let's say we'll come back at 12:20. It's 12:07 right now. We'll come back at 12:20. I'm gonna just restart my computer just in case there's something going on I'm not aware of, because it has not been laggy like this before. So I'll restart the meeting and we'll continue back here at 12:20. All right, and I'll pick up with one of these. And then as soon as we're done with that, we're gonna do some more applications or some applications. And then we start linear equations and linear graphs. All right. So I'm going to close us out. We will come back in about 12 minutes or so. There we go.